Since the discovery of the interstellar comet 3I/Atlas this past July, astronomers around the world have been paying extremely close attention to its movement and behavior as it travels through our solar system. This object is only the third confirmed visitor from another star system, following the earlier detections of Oumuamua in 2017 and 2I/Borisov in 2019, which makes 3I/Atlas an especially important target for scientific study. Because such travelers offer rare and valuable clues about how planetary systems form and evolve elsewhere in the galaxy, scientists immediately recognized that the comet presented a unique opportunity, one that might not come again for generations. As the icy wanderer brightened while approaching the inner solar system, the public's imagination brightened alongside it. Social media posts, online videos, and speculative forums began circulating rumors claiming the object might be an alien spacecraft or some sort of technologically advanced probe, particularly during the recent 43-day government shutdown, when NASA was unable to release new images or comment on developing observations. The absence of official information created a vacuum in which conspiracy theories could flourish, and the comet quickly became the center of sensational discussion, far beyond the scientific community. Once the shutdown finally ended, NASA held a long-awaited briefing designed to provide clarity and calm the growing wave of speculation. During this event, the agency shared data collected by more than 20 missions located throughout the solar system, each offering a unique viewpoint from which to observe the object. NASA's goal was to assemble the most complete and accurate portrait of 3I/Atlas to date. The first and most immediate message they delivered was direct and unambiguous. 3I/Atlas is entirely natural. It is not an alien craft, nor a disguised technological object, nor anything that would suggest an extraterrestrial intelligence. It behaves exactly like a comet should, according to the laws of physics and the patterns astronomers have documented for decades. NASA Associate Administrator Amit Kshatriya emphasized this point early in the briefing by acknowledging the public's hope of discovering life elsewhere in the universe, while firmly stating that this particular object was simply a comet. It was formed from the icy and dusty material orbiting an ancient star, carried across interstellar space, and eventually swept into our own solar system by gravitational encounters. 3I/Atlas was discovered on July 1st by the Atlas telescope in Chile, part of a NASA-funded system designed to scan the sky for rapidly moving or changing objects. From the moment researchers analyzed its path, they could tell the comet originated far beyond the boundaries of the solar system. Its unusual trajectory, which is shaped like an open hyperbola rather than a closed elliptical orbit, indicated it was not gravitationally bound to the Sun. Objects with such paths arrive only once, pass through our system, and then continue onward into deep space. That knowledge alone made the discovery remarkable. Scientists also realized that by studying the comet's composition, they could gather chemical clues about a distant planetary system, one likely older than our own. Each interstellar visitor carries with it a frozen archive of the conditions under which it was formed. By measuring its gases, ices, and dust, astronomers can piece together information about stars and environments that might otherwise be impossible to study directly. Despite this scientific excitement, speculation about alien involvement erupted soon after the discovery. About 2 weeks later, a trio of researchers, including Harvard astrophysicist Avi Loeb, posted a non-peer-reviewed preprint arguing that some of the comet's features might hint at disguised or even hostile alien technology. Loeb had previously suggested that Oumuamua, the first known interstellar object, might have been an extraterrestrial probe, so his new claims quickly attracted attention. When SpaceX CEO Elon Musk casually commented on a podcast that forces beyond gravity might be affecting the comet's motion, the rumor mill accelerated even faster. The story spread beyond scientific circles into mainstream pop culture when Kim Kardashian jokingly asked NASA's acting administrator on X to share the tea about this mysterious visitor. With each viral mention, the idea gained new life. NASA officials addressed the controversy head-on during the briefing. Amit Kshatriya clearly stated that nothing about 3I/Atlas suggested technological origin. Nikki Fox, the Associate Administrator of NASA's Science Mission Directorate, reinforced that none of NASA's observations across multiple instruments showed any technosignatures or technological patterns. Every bit of evidence, shape, behavior, chemistry, brightness, and motion, aligned perfectly with what scientists expect from an ordinary comet. She also reassured the public that the comet posed absolutely no danger to Earth. Its closest approach would still leave it about 170 million miles away, far more distant than even Mars. It would not come close to any major planets, not even when it crossed the orbit of Jupiter in spring 2026. According to Fox, everything in our solar system will be just fine. One of the challenges early on was that the comet's position placed it on the opposite side of the Sun from Earth. This angle made it extremely difficult for ground-based telescopes to observe properly. To overcome this limitation, NASA organized a coordinated multi-mission planning session in August, bringing together dozens of spacecraft teams scattered across the solar system. Each spacecraft had its own vantage point, some orbiting Earth, others circling Mars, others en route to distant destinations. Tom Statler, the lead scientist for small solar system bodies, compared the task to watching a baseball game from seats all around a stadium. Everyone is trying to capture a picture of the same fast-moving ball, but no one has the perfect view. Still, when all the perspectives are combined, the result is far more detailed than any single camera could provide. Mars proved especially useful because it happened to be positioned more favorably relative to the comet. In early October, the Mars Reconnaissance Orbiter captured images showing the comet as a fuzzy white sphere with a developing coma of dust and gas. Around the same time, NASA's MAVEN mission detected ultraviolet signals, nicknamed Science Wiggles, that revealed hydrogen gas streaming from the comet as sunlight vaporized its water ice. By combining this data with observations from the Swift telescope and the powerful James Webb Space Telescope, scientists were able to estimate how quickly the comet was releasing water, an important clue to its age and formation history. Other spacecraft, even those not specifically designed to study comets, contributed additional snapshots. In September, the Psyche asteroid mission photographed the comet from more than 33 million miles away, capturing a faint but useful glow. A week later, the Lucy mission, on its long journey toward Jupiter's Trojan asteroids, observed 3I/Atlas from a completely different angle, helping scientists reconstruct the three-dimensional structure of its dust tail. The NASA European SOHO spacecraft, designed to monitor the Sun, unexpectedly detected the object in mid-October even though it was considered too dim to appear in its usual images. Perhaps some of the most striking data came from the Hubble Space Telescope and the James Webb Space Telescope. Hubble, still performing remarkable science after more than 35 years in orbit, photographed the comet from nearly 300 million miles away. Its images revealed a pear-shaped coma and allowed astronomers to narrow down the size of the nucleus to somewhere between 1,400 feet and 3.5 miles wide. JWST, meanwhile, provided the first infrared examination of an interstellar object since its launch. Its instruments detected an unusually high ratio of carbon dioxide to water ice, far higher than what is typically seen in comets originating from our own solar system. This chemical signature suggests that the comet formed in a harsher radiation environment, possibly around a star older and more evolved than the Sun. The composition of its ices tells a story of conditions that shaped it billions of years ago, before it was ejected and sent drifting through interstellar space. While all this data is exciting, scientists caution that their interpretations remain in the early stages. As Tom Statler emphasized, this is just the beginning of the scientific process. The comet will continue to be observed as it moves through the solar system, and new details will undoubtedly emerge. Each measurement, each spectral reading, each faint image adds another piece to the puzzle of its origin. But even at this early point, the evidence overwhelmingly supports one conclusion. 3I/Atlas is a natural interstellar comet, carrying with it a chemical fingerprint from a planetary system far older and more distant than our own. It is not an alien probe, not a threat. and not a mystery beyond scientific explanation. Instead, it is a rare and remarkable messenger from another star, offering astronomers a fleeting chance to study the materials and conditions that exist far beyond the reach of our telescopes.